Recording in progress.
Yeah, give me 1 minute. There are certain technological problems. Okay, now it has been rectified. Sorry for the delay. So we'll finish around like 8:10. I think we finish the first lesson. So, and I gave you some homework as well. Can one of you let me know whether I have uh, discussed about the solubility part with you? I think not. Can one of you let me know? We discuss only up to diffusion, right? Solubility anyway. Like I won't be doing the full lesson. That part, like I told you, that will be taken later. But simple idea regarding solubility will be explained before I move into the crystallization part. At least to the chat, can someone confirm we finished the diffusion part last week? Please, otherwise it's taking time. Okay, thank you for the response. So uh, today I'll start the second lesson. Don't worry about the solubility part. I'll be explaining that thing. And before moving to crystallization part, in the separation techniques, I'll be taking like uh, small part of solubility, like before I discuss about crystallization. So when we consider chapter 2, very important chapter, elements, compounds, and mixtures. Elements, compounds, and mixtures. Like, first of all, I'll give you a brief understanding about like what we are going to discuss here. Then later on, like we'll get to the lesson. Give me 1 second to check whether I have started the recording. Yeah. Okay. So I just wanted to check whether like recording is fine. Okay. First of all, I'll give you a brief introduction about like this lesson, what we are going to learn. So here we are learning about classification of matter based on their chemical nature. That is the first thing which we will be doing. In there, like matter is composed of two main parts. Chemically, we can divide into pure substances and mixtures. Then pure substances can be further divided into elements and compounds. Then, apart from these things, I'll be discussing some theory around the molecules as well. Although that will be in the textbook, that is in the next lesson, but I'll be discussing about molecules. And when you take pure substances, so this part also not that much discussed in the textbook, but without discussing about the pure substances, it is like somewhat not appropriate to discuss about elements and compounds. So I'll be giving a full introduction about pure substances as well. So based on physical nature, matter can be divided into three main parts: solid, liquid, gas. We discuss about that thing. Now, chemical nature, we are going to discuss uh, this classification regarding matter. Then later in the lesson, in the syllabus, here they are focusing some attention to the differences between mixtures and compounds. That's a separate area for that as well. Then later we are talking about separation techniques, mixture separation techniques. So we are talking about under that five main areas: filtration, crystallization, this is where the theory regarding solubility is needed. So I'll be giving you some like brief insights regarding what is exactly solubility. The idea of saturated solution is needed when we discuss that part. Then Third one will be simple distillation. Fourth one will be fractional distillation. And finally, we are discussing about a mixture separation technique called as paper chromatography. If you remember the science book, which was in grade 7, already they have discussed simple distillation, paper chromatography. In grade 6 book, filtration is there. Crystallization also some to some extent that is there in certain parts, but fractional distillation is a fully new thing. But don't worry, like I'll be discussing all of the things from the very beginning. So this is the basic structure of the chapter 2. So the topic is elements, compounds and mixtures. First of all, we'll be taking matter, the classification of matter based on the chemical nature into two main parts, pure substance and mixtures. Then we are moving to elements, compounds. When we consider mixtures in grade 7, they are talking about three types of mixtures as colloids, suspensions, and solutions. If you remember, okay, colloids, suspensions, and uh, solutions. And there, in chemistry textbooks, there is another classification of mixtures as homogeneous mixtures and heterogeneous mixtures. But that kind of knowledge is not expected at the O level regarding mixtures. We are just discussing what is a mixture and how it differs from a pure substance. So we are not going into details regarding types of mixtures. So if someone wants, like, you can have a screenshot. So this is the basic summary of the lesson. Okay. I'll give you a, like, 5 seconds to take a screenshot if you want. Then I'll erase. Okay, that's enough. And next day, I'll be bringing some structures, 3D structures, where I'll be demonstrating like what exactly is an element, how it differs from a compound, then like how elements and compounds can be related into molecules. So that part which I am discussing today as a theory in the board will be taken further in the next day using 3D structures. So you will be having a very good idea about these areas in next week. Today also, no problem, like these are very simple concepts. You will be able to understand. We will complete the note, but when I'm coming on the next day, I'll be bringing the structures. Next Thursday, results will be released at 2 p.m. hopefully. So I'll let you know the success of our students as well into the groups by next week. And like I'm, as I promised to you, like I'm working on like how to give you guys a practical experience as well. There are 12 main practicals in the syllabus. Apart from that, there are certain other processes which we come across in this lesson, like distillation, simple distillation, fractional distillation. Like, if I could give you some insights regarding how exactly this happens in the real scenario, I hope that would be better. But first of all, I'm working on the main practicals which is in the syllabus. So that is in progress. And hopefully, like before the end of a few months, like within like 2 to 3 months, I'll be able to fully conduct like all the practicals and have the necessary videos because a lot of process involved. I need to make a website as well. I'm hoping to release them as study packs. So definitely, I can guarantee like as per the discussions which I had, like for the time being, I believe like I'll be able to deliver that to you as well. So that is a update from my side. I'm working on that within like a period of 3 months. It will be uh, like available for you guys, and like that is more than enough. Like because we are having around 2 years for the exams. Not 2 years, like around like 1 year and around 8 to 10 months. Okay, then we'll start the lesson. First, I'll start with. First, I'll do the theory part regarding the classification of matter. After we fully finish that part, or else like after we discuss one part, we'll go to the tube. We'll finish, complete the tube. We'll do like that. Then classification of matter based on the chemical nature can be divided into two main parts as pure substances and mixtures. Pure substances can be further divided into elements and compounds. So, for elements, like I need responses from you. Can you name some elements, like, and at the same time, can you name some compounds? At least like one element, two elements and two compounds, which you know at the moment. So I request an answer from each one of you. Send it as a private message where others cannot see your answer. Two elements and two compounds as examples. And like I cannot force you in these situations, so don't wait until like I repeat like 3 to 4 times to give an answer. So please respond as soon as possible, then we can save our time. So I'm waiting for the answers. Hurry up, please. Please send it to the chat as a private response. Two elements and two compounds, which you know. I believe like all of you know about like some examples for the elements. Okay, I got some responses. Let me check. Compound, yes. Okay, hydrogen, sulfur, those are the elements. Sandil, what about the compounds? What about others? Only two responses I received. Sanuj and Sanuja, can I have an answer? Please don't waste time.
Sir, I send you.
Oh, wait. I cannot see. I cannot see the answers, Sanuja. Okay, that's fine. That's fine. However, don't send
So
it
to
by
the
no.
Apollo Institute one or
No, no, no. To
your
my
name
one.
one.
To my
Sir,
one.
I send you to your one.
Yeah, yeah, please.
Okay,
Not,
sir.
not to the other one. Yeah,
Can
that's
I
good.
send you again?
Yeah, that's fine.
Okay, sir.
Okay. So this is easy. We'll have some examples here. Elements, I'll take hydrogen. Symbol H. Oxygen. Symbol O. Compounds, I'll take water. H2O. Carbon dioxide. Symbol CO2. Okay. Yeah. Before we proceed further, can you please have a note regarding this classification in the very first space which I have given to you here, this part. Please write this classification. Then I'll come to the explanation. Yeah, I hope time is enough. Now, please listen. When we consider matter based on the chemical nature, based on the chemical nature, Matter can be mainly divided into pure substances and mixtures. First of all, what is meant by a pure substance? So I have given a definition for pure substances. Pure substance, matter that has distinct properties and fixed composition. Matter that has distinct properties and fixed composition can be classified as pure substance, and they have mentioned very important thing, which does not vary from sample to sample. So whatever the elements or compounds, they come under pure substance. So I'll take one example: water. We know that is one, that is a compound and it is coming under pure substance. All right, somewhere here I'll take two samples of water. One from a lake and one from the ocean. And I'll purify those and I'll obtain pure water, because there are certain dust and debris, especially in lakes, these things, and in ocean, like water is hugely concentrated with salt. So I'll remove all the other impurities, and I'll, in whatever the way, I'll take pure water from both these samples. So then if I measure the boiling point of water, what would you think? I need your opinion. Do you think the boiling point of water in sample, we'll consider this one as sample E, the boiling point of pure water which is received from sample A is equal to boiling point of pure water which is received from sample B, or they differ? So if you tells like the boiling point of sample A will be equal to sample B, you can send your answer as yes. If that is not the case, you can send your, which means if they are different, you can send the answer as no. Quickly.
So what did you say? I didn't hear properly. I had a signal issue.
Okay. So Sanuja, what I mentioned was, I'm taking two samples of water, one from a lake and one from ocean. Then what I'll be doing is I'll be taking pure water out of this sample, and this sample as well, because the water sample from a lake or ocean, they are like mixed with lot of impurities, which means other substances. So that is not pure water. So I'll extract pure water from both the samples. Then what do you think about the boiling point of pure water in this sample and this sample, whether they are equal? If it is equal, you can send your answer as yes, or they are different. If you think it is different, if you think the boiling point of these two samples are different, you can send your answer as no, either yes or no. Quickly. So please try to give the responses as soon as possible. No. Okay. Yes. Sanuja, I cannot see any response from you. I don't know whether.
Yeah, I send you.
Yeah. Please try to send to like Apollo Institute, that thing.
Okay, teacher. Okay, sir.
Okay. Yeah, I see your responses. So you have sent to my other number. Right. Now I'm receiving those things. Yeah. Okay. Two of you say yes, and one is saying no. Actually, the boiling point of this sample, 100 Celsius. at normal atmospheric pressure. And boiling point of the sample also 100 Celsius. You know, when we consider water, freezing point is 0 degrees Celsius, boiling point is 100 degrees Celsius. In both the samples, it will be the same because those are pure water. We don't care about the original samples. Definitely, boiling points will be different in those two samples. But I told you I'm extracting pure water from both the samples. Then, like, what are the reasons for it to be different? Definitely, that is equal. So that is what they are telling. Like pure substances are the substances which are having distinct properties and uniform composition. I'll come to that second thing. So this is about the properties I'm talking. Melting point is a property of a substance. Sorry, boiling point. Boiling point is a property. What they are telling? Matter that has distinct properties and fixed composition that does not vary from sample to sample. But when we consider mixtures, that varies. Okay, I'll take a good example. If we consider a cup of tea, if we consider, I hope this area you can see, yes. So if we consider a cup of tea which is made by your mother at the morning, okay. So every day there will be same ingredients. She will be using milk powder, then tea powder, then water or hot water mainly, then sugar. These are the main constituents of a cup of tea. But like definitely like the taste differs, like not to a significant extent, but at a little margin, like taste differs from day to day. So although the substances are the same, if we consider a cup of tea from two different days, the composition changes definitely. It is always not the same level of sugar. Okay. So what is a mixture? It is a combination of two or more substances, and that composition of those constituents in the mixture can vary from sample to sample. When we consider pure substance, now listen very carefully. So I'm going to explain the real difference between pure substances and mixtures. When we consider pure substances, there is only one substance there. For an example, hydrogen, only one substance. That is an element. If we take a compound, water, one substance is there. But mixture, we took an example, a cup of tea. So in this one, few substances are there. Milk powder, then tea powder, then sugar is there, hot water is there. Okay, more than one substance are there. One of the best examples in the normal life is air. When we consider air, it is a mixture of few gases, mainly nitrogen, 78% is there, carbon dioxide is there, then argon is there, oxygen is there. Nitrogen 78%, oxygen 21%, carbon dioxide 0.04%, and argon 0.9%. So these are the we can consider these are main constituents. So we can use the word components of a mixture. Components, better word, which is used in the textbook as well. So in a mixture, few components are there or few substances are there. But in a pure substance, only one substance always. Hydrogen, one substance. Oxygen, one substance. Water, one. Carbon dioxide, one. So here, two or more components are there in a mixture. And as I mentioned to you, although the same components are there in two different samples, the composition can change definitely. Okay, but when you consider pure substances, I explained to you their properties remain unchanged at the same time. They have a fixed composition. So when you consider pure water, it is the formula is H2O. Always in water, whatever the sample, the like which they take, it is the formula is always H2O, and the ratio between hydrogen to oxygen is 2 to 1 always. Which means in a molecule of water, two hydrogens are there and one oxygen is there. Again, I will repeat. Listen carefully. I'll come to elements and compounds later. First of all, we should understand the differences between pure substances and mixtures. When we consider matter, based on the chemical nature, matter can be mainly divided into pure substances and mixtures. When we consider pure substances, those are the substances. First of all, you should know that is only one substance there. And those are the substances which are having distinct properties and uniform or fixed composition, which does not vary from sample to sample. So under properties we discuss, we take two water samples from two different sources, then we extract pure water out of it, and what happened to the boiling point? Always same, which does not vary from sample to sample. That is regarding properties. Then regarding fixed composition, whatever the water sample, always the formula will be H2O. The ratio between hydrogen to oxygen will be always 2 to 1. Then mixtures. Definitely, more than one substance is there, it can be two or more. And the composition of constituents in a mixture can vary from sample to sample. We took as an example a cup of tea, which is being made in 2 days, will be different from one another. Okay, so although the substances are the same, their composition definitely might vary. Another example was air. Air is a like mixture of gases. Mixture of gases. Then, if we take another example, salt solution, a mixture of salt and water. Sugar solution, a mixture of sugar and water. So, two or more components or substances are there in mixtures. I hope the explanation is clear to you. Okay. You don't need to write these things. If you think something is important, like if you want certain notes, like for an example, distinct properties, like by just merely looking at the date, you won't understand. So as a note, like somewhere like using a sticky note, I don't mind. Like if you have this kind of a note, okay. Then, however, come to the pure substance. I have mentioned extra note because this is not in the book. Matter that has distinct properties and fixed composition that does not vary from sample to sample is referred as a pure substance. Actually, I think I have kept the space to draw this thing regarding distinct properties and fixed composition. Remember, this is not needed. But you will understand without learning about pure substance, it is not appropriate to move in directly into elements and compounds. That is why I discuss about this thing first. So, could you please have a small note regarding this one? This part and this part. I know the space is not that much enough, but like try to manage the space like by drawing a diagram in a small manner. Okay, I hope that is done. Then we'll come to elements and compounds. These are very small things. There's uh, a small space under pure substance, but try to manage. So then we'll come to elements and compounds. Although these things are somewhat small, like you might have like get used to these things in previous grades as well, but it is very important. We have lay down a good foundation in chemistry, especially in these lessons. Elements. Elements are substances that cannot be split into simpler substances by chemical means. An element contains only one type of atoms. So, if we take hydrogen element, can we split it further? No, we cannot do that. And they are consisting of only one type of substance, nothing to explain there. In the book, in page number 14, under elements, they have given three diagrams. So you need to draw these three diagrams as a homework. That is why I have left the space there. Okay. In page number 14, page number 14 of the book. So under elements, three elements are there. You need to draw them under the space given. So as a homework. Then come to the next page. Note. A better way of saying it would be that all the atoms in an element have the same atomic number. Most elements consist of mixture of five set of which have the same atomic number but different mass number. This is something in the extension note. Uh, First of all, like I'll finish elements and compounds, molecules, these part. I'll finish the entire thing up to mixtures. Then, if we have time, we'll come to this point. Okay. There's something which I need to explain. I need to erase this note. Okay. So, last point in elements. Most of the elements occur naturally, such as hydrogen, helium, and sulfur. Some others have to be made artificially, such as Einsteinium. Okay, certain elements in the periodic table like have made artificial. One of the examples is Einsteinium, but most of the elements are naturally present in nature. Okay, then compounds. Compounds are formed when two or more elements chemically combine in fixed proportions. I'll take water as an example. When we consider compounds, two or more elements are there. What are the elements? Hydrogen is there, oxygen is there, and they are chemically combined as well. They are chemically combined. That is why they are together. So two or more elements um, which has been chemically combined in fixed proportions. In fixed proportions. If we take water, always hydrogen to oxygen ratio is 2 to 1. I'll take another example. Carbon dioxide. What are the two elements? Carbon and oxygen. So the ratio between these two elements 1 to 2. So what is the definition? In a compound, two or more elements. Any compound like which is consisting of more elements, nitric acid I'll take. Hydrogen, nitrogen and oxygen, three elements are there. So a compound means a combination of two or more elements which is chemically combined, not physically. Physical combinations are there in mixtures. We will discuss later. In a compound, two or more elements chemically combined and in fixed proportions. So the ratio between the different types of elements won't change. Okay, I hope that is clear to you. So under compounds also I have given a space. In page number 15, three diagrams are there. You need to draw these three diagrams as a homework. And please use different colors to show different elements. Huh? So they have indicated the element, indicated the compounds, the elements of a compound in different colors. If it is water, oxygen with one color and hydrogen with another color. So likewise, you also use two different colors in order to showcase like in a compound, different types of elements are there. So when we consider elements and compounds both coming under pure substance, what is the difference between these two? In elements, only one type of substance are there, or one type of atoms are there. In here, two or more different types of atoms are there. Example, carbon dioxide, two different types of atoms in two different elements, carbon and oxygen. Hydrogen, two, hydrogen, oxygen. Nitric acid, hydrogen, nitrogen and oxygen. Two or more different types of atoms are there which are chemically combined in fixed proportions. The ratio between the elements won't change. Okay. Then page number 15, three diagrams are there. You need to draw that as a homework. Then molecules. What is a molecule? Molecule is a combination of two or more atoms joined by covalent bonds. Very important. Covalent bonds. There's a separate lesson for covalent bonds. That is chapter number 8. We'll learn about covalent bonding there. Okay. Just for the time being, you don't worry about this word because it needs time for you, for me to explain what is covalent bonding and what is the difference between different types of bonding. Basically, like in the syllabus, they are talking about three, like the main types of primary bonds, which are ionic bonds, covalent bonding, and metallic bonding in the lesson number 7, 8, and 9. Okay, so we'll take those things separately. For the time being, you just remember molecule is a combination of two or more atoms joined by covalent bonds. Example, what is a molecule? What is a molecule? Why combination of two or more atoms? Obviously, I will be taking examples which have been connected with covalent bonds. So you don't need to worry whether they are having covalent bonds. I'll be taking some examples which are having the covalent bonds. So that is obvious. So then we need to check whether it is a combination of two or more atoms. When we consider water, two hydrogens are there and one oxygen is there. So altogether three atoms are there. So combination of two or more atoms, that is a molecule. And at the same time, this is a molecule. What is a molecule? At the same time, it becomes a compound as well, because in a compound, two or more different types of elements are there. Number of atoms is 3. Combination of two or more atoms produce a molecule. At the same time, it is a compound as well. Why? It is a compound as well because compound is a combination of two or more elements. Two elements are there, hydrogen and oxygen, so it become a compound as well. Then actually these are called as molecule of a compound. Then I will take another example. Nitrogen. Nitrogen element exists in nature as diatomic molecules. Diatomic means combination of two atoms. Okay, in nature they don't exist as single atoms. So you know nitrogen gas, right? So nitrogen gas is composed of two nitrogen atoms. When we consider nitrogen, it is a combination of two atoms, no? Two or more atoms that becomes a molecule. Molecule. At the same time, it is an element. It is an element because in element only one type of atoms are there. Two nitrogen atoms. Atoms of the same type, so it will become an element. I hope this part of the board is clear to you. Oh no. Okay. Yeah. Okay, I'll readjust the camera later. Okay. So this is a molecule at the same time, since it is composed of two atoms of the same type, two atoms of the same type. If it becomes an element as well, because in element only one type of atoms are there. We don't care about the number of atoms. If it is only one type of atom, it become an element. Okay. So on the molecules, can you write these two examples? Water, a molecule and a compound. Nitrogen, a molecule and an element. Definition have been given. You don't worry, like in the next day, if you don't understand anything, don't worry. In the next day, I'll be like clearly explaining these things with 3D structures. Ball and stick structures will be used. So definitely you will have a very good understanding. Then mixtures. Okay. So can anyone like give me a response using raise hand option, like if this is clearly visible to you? Because I adjusted the angle to some extent using raise hand option. Can anyone respond to me? Whether this is okay with? Can anyone give me a response, please? I made a little adjustment to the camera. So if something is not clear, Sandip, can you give me a response? Whether it is okay? Okay, okay, thank you. Yeah. So I'll erase about this part now. We have completely discussed. Then last part is mixtures. Mixtures are formed when two or more substances physically combine together. Substances making up a mixture are called components of a mixture. Okay. So I couldn't mention to you like regarding the things that you need to highlight. Come to the very first page of the tube. Come to the first page of the tube. Under elements, and remember, you don't need to by heart the definition of pure substance. That is not in the book. So under elements, please highlight firstly the word elements with orange color, and with green color are substances that cannot be split into simpler substances, with yellow color by chemical means. Then with pink color highlight only one type of atoms in the next sentence. Only one type of atoms. With green color highlight an element contains. An element contains. Then with the pink color only one type of atoms. Come to the next page. Compounds. Highlight the word compounds with orange color. Green color are formed when two or more elements. Yellow color chemically combine in fixed proportions. Molecule. Highlight a molecule, that part with orange color. Then with green color is formed when two or more atoms chemically bonded. When two or more atoms chemically bonded. Then with yellow color highlight by covalent bonds. Then mixtures. Highlight the word mixtures with orange color. Then with green color highlight are formed when two or more substances with yellow color highlight physically combined together. Physically combined together. Substances making up a mixture are called components of a mixture. Highlight with pink color. Components of a mixture. Accordingly, mixtures are formed from the following combinations. A mixture is made up of two or more substances, and they are considered as components of the mixture. These components can be either elements and elements, or else compounds and elements, or else elements and compounds. As an example, I'll take first one. In a sealed container, assume there's a mixture of hydrogen and oxygen randomly. There's a mixture of hydrogen and oxygen. What is hydrogen? An element. Hydrogen is an element. Oxygen, that is also an element. Because when you consider hydrogen, that is made up of only one type of atom. Oxygen also same. Again, you can't see, no. Okay, let me take it to the top. And like from October onwards, hopefully we'll be having a smart board as well. So where it will be really good, like you'll be getting a very good experience. So give me some time, like these updates will be done by the institute. So we are working on these things. There's a construction ongoing where they will uh, have a dedicated space for online classes. So accordingly, I believe like they will fix a smart board as well. Then your learning experience will be very good. So I think the work will be finished by the end of September or October. Okay, within like 2 months, it will be ready. So then we don't have these problems of managing the space. Like it will be a very broad thing where directly the connection will be set up to the entire board. So I can write like with a greater flexibility. So when we consider elements as an example, I'll take a mixture of hydrogen and oxygen. Hydrogen and oxygen. Hydrogen is an element and oxygen also an element. They are composed of same type of atoms. So this is a mixture of elements and elements. So that is one way the mixtures can form. Only elements will be there. Two or more substances. There can be hydrogen, oxygen, and nitrogen as well. We don't mind. Only elements should be there. Then compounds. I'll take a gaseous mixture which is made up of carbon dioxide and another gas, sulfur dioxide. Okay, carbon dioxide and sulfur dioxide. Randomly, they will be spaced in this same mixture. When you consider carbon dioxide, it is made up of two elements. Compound is a substance which has been made from two or more elements. Carbon and oxygen is there two elements, so this is a compound. Sulfur dioxide. Sulfur is one element, oxygen is another element, so made up of two elements. So it is also a compound, a mixture of compounds. Compounds. So here the components are elements, here the components are compounds. Then a mixture of elements and compounds. Example, a gaseous mixture which is made up of hydrogen, water, sorry, no, not water. There is not a gas. No. Water vapor we can consider, but I'll take a direct gas. Carbon dioxide. Now hydrogen is an element. Carbon dioxide is a compound. So it is a mixture of elements and compounds. Okay. So those are the main ways of forming mixtures. Either it can be formed only of elements, the components will be only elements, either it will be only compounds, or else it will be a mixture of elements and compounds. So under those three, can you please mention this example? Please draw this box, mention those different gases, and underneath the box you need to mention what are they, like either element or compound, like that. Okay. And these words, I think it is not that much clear. This is a compound and this is element. So in the second page, elements are there. In the next page, you can see compounds, the B part and C part, elements and compounds. Underneath, under those spaces, you need to write these three. Then we'll come to the differences between mixtures and compounds. When you are done with the work, please give me a response using raise hand option. Then I will consider you have done the work. Please. පොද රෙස්පොන්ස් වල ඩිලේ එකක් තියෙනවා. ඒව කරන්න එපා. ක්ලාස් ටයිම් එක තමයි මිස් වෙන්නේ. හරි. When you are done, please give a response using raise hand option. Keep the hand raised. Then, okay, Sandil has completed. Chenuka and Sanuj. Okay. Then we have finished the entire. As I mentioned to you, at last I'll be explaining that part which we miss. Please come to the second page. One point we skip in elements. A better way of saying it would be, this is in the second page, first bullet point. A better way of saying it would be that all the atoms in an element have the same atomic number. Most elements consist of mixtures of isotopes which have the same atomic number but different mass numbers. You might not understand what they are telling. So let me explain. Then you'll be able to understand it clearly. But this is something which is in the extension work, so which is not that much concerning in the exams, but this is a fact which is mentioned in the book. So what they are really telling, when we consider an element, under the definitions they mention element is consisting of only one type of atoms, only one type of atom. Example, if we take hydrogen, hydrogen has atoms of hydrogen. But theoretically, there's something more. When we consider hydrogen, in the same element, there are three isotopes. I don't remember whether I explained the same example under isotopes, but when we consider hydrogen, there are three main isotopes of hydrogen: hydrogen 1 1, hydrogen 2 1, hydrogen 3 1. This is considered as protium. This is considered as deuterium. These are some names which is given for the isotopes of hydrogen, and this is considered as tritium. Let me check the spellings for protium. I don't remember exactly. Yeah, that is correct. When we consider these three isotopes, I'll mention about the number of protons, electrons, and the neutrons. Yeah, you can see, right? When we consider proton number, atomic number of a particular element is equal to the number of protons. So proton number is 1. Okay, I think I didn't mention you regarding the isotopes because that will be taken in the next lesson. For the time being, I'll just give a brief explanation. I'll come to this point again in the next lesson. Yeah, atomic number, that part is in the next lesson. So number of protons, but you have done this thing in grade 8 as well. So number of protons does not change for an element, that is same. Number of electrons will also be same, but number of neutrons will be different. Okay. So basically, you just remember subatomic particle composition differs in these isotopes, especially the number of neutron changes. That is why three types of atom. That is the basic data which you need to know. When we consider an element, we say it is made up of only one type of atom. But when we move to the isotopes of elements, this concept is there in grade 8 as well. Isotopes are the atoms of the same element which are having same number of protons but different number of neutrons. When we consider the atomic structure, that is the next lesson. Protons and neutrons are in the center of the atom, which is at the nucleus, and electrons are surrounding the nucleus in energy levels. So the number of proton doesn't change for a particular type of element. So whatever the atom you take, number of protons will be same. Electron number will also be equal to the proton number due to a particular reason. We will be discussing that in the next lesson. And neutron number change across the isotopes. So in the same element also, what their point is, in the same element also there are different types of atoms. So theoretically, this is not the best definition. Like this is not the best way how to explain an element. Ideally, it should be better for us to mention like this. When you consider element, atoms of an element are having the same atomic number, which is atomic number means the number of protons in an atom. Atoms of the same element are having the same atomic number. That would be the best way to mention, because in a particular element also there are different types of atoms. So for us to mention only one type of atom in a particular element is theoretically not that much correct. But you don't need to consider, since that is in the book I explained to you, that is my duty to explain to you the things in the book, the facts. At your level in the exam, if they mention like this, consider this one as correct. Atoms are consisting of only one type of atom. Sorry, elements are consisting of only one type of atoms. If you understood that concept, could you please give me a response using raise hand option? If you understood the concept, Sanvil, Sanuja, can I have a response?
So I didn't understood.
Okay. Yeah. If you don't understand, you don't worry for the time being, because I'll be uploading this recording to the group as well. So when we discuss the isotopes in the next lesson, then you will be able to understand what I'm exactly explaining here. Okay, because isotopes will be taking in the lesson number 3. Atoms of the same element which are having same number of protons but different number of neutrons are considered as isotopes. So for the time being, you don't need to worry. This part will not be tested in the exam as well.
Okay, sir.
Okay. So I'll move to the next part. So I'll continue the class for like, since there was a delay due to like technical errors, I'll be continuing the class until like 8:10. Okay. 8:15 maybe. Then we'll have a small break of like 2 to 3 minutes. You can freshen yourself and join with the discussion in a short while. Okay. Then come to the next part, differences between mixtures and compounds. Differences between mixtures and compounds. Okay. Come to the table. First one, proportion. Compounds, elements are in fixed proportions, and mixtures, substances can be in any proportion. I discussed earlier as well. So, when we consider compounds, in a compound like water, we took an example earlier. The proportion between hydrogen to oxygen in water is 2 to 1. So that is fixed. Whatever the water sample you take, if you take a water molecule, the combination of like the ratio between hydrogen to oxygen is always fixed proportion. That is 2 to 1. But if we take a mixture, for an example, we will take 2 cup of tea from 2 different days, as I explained to you earlier. All those same constituents are there, they are proportions. Proportion of what? Here the proportion of elements in a compound. Here proportion of components. Components in a mixture. What are the components? Milk powder, tea powder, hot water, and sugar. So the components of the mixture, the proportion changes from sample to sample. So we discussed that earlier as well. Substances can be in any proportion. Second one, properties. Compounds. Properties of a compound is quite different from its constituent elements. And in a mixture, each component of the mixture keep its own properties. When we consider water, how water has been formed by reacting hydrogen with oxygen. That is how water is formed. When we consider hydrogen, that is a gas. When we consider oxygen, that is also a gas. But when we consider water, that is a liquid. The properties of the components are entirely different from the compound. So that is what they are talking here. Properties of a compound is quite different from its constituent elements. So the properties of liquid water is quite different from its constituent elements, which is hydrogen and oxygen. Hydrogen is a gas at room temperature. Oxygen is a gas. Water is a liquid. And the properties of a gas are completely different from properties of a liquid. That is what they are explaining under that point. But when we consider a mixture, for an example, I'll take a sample of air. It is mainly the gases are nitrogen, oxygen, carbon dioxide, and argon. There can be certain other noble gases like krypton as well. But these are the four main constituents. Although they are as a mixture, nitrogen keep its own properties to nitrogen. Oxygen has its own properties. Carbon dioxide has its own properties and argon has its own properties. Although they are in a mixture, they don't lose their original properties. That is what they're exactly telling us. When we consider, for an example, when we consider oxygen, it is a support of combustion. So oxygen is needed for combustion. So that property is there with oxygen, although that is in a mixture, because in a mixture these components are not chemically combined. They are just physically, they are mixed with each other. So which means their original properties remains with themselves. That is what they are exactly explaining. So here hydrogen and oxygen, when it is combined, so this is a totally different substance, new substance. So the properties of these elements are not there anymore in water. You can understand very easily. But here, although they are in a mixture, since they are not chemically combined, so they will have their original properties with them, although they are in a mixture. Hands up who understood that part. Using the raise hand option. Please give me a quick response. Sanuja? Okay, thank you. You can lower down your hand. Okay. Can you please have this small note under the space which I have given? This thing. Then under mixtures, you can mention like individual gases retain their original properties, their properties. Okay. So I have left a small space. Underneath that, you can mention. Then ease of separation. Elements in a compound can be separated by chemical methods, and components in a mixture can be separated by physical methods. Okay. Third one, ease of separation. Actually, they have, if you look at the textbook, they have given these points like as a paragraph, but I have like made it nicely into a table where you can easily grab the differences between these two. So ease of separation, how easy to separate the constituents. For an example, when we consider compounds, we can separate the elements in a compound by chemical means or chemical methods. What are the examples? For an example, when we consider water through a process called as electrolysis, we can separate water into hydrogen and oxygen. We can separate this one into its constituent elements using the process of electrolysis, which is our lesson number 10. That is some kind of hard concept. We will get to know about this thing in chapter number 10. Very interesting lesson. We cannot use physical methods. Physical methods means, so those are the mixture separation methods which we are going to discuss in this lesson, which I mentioned to you at the beginning of the lesson in the summary. Filtration, simple distillation, fractional distillation, crystallization, and paper chromatography. Those are the five main techniques which we are learning under this lesson, but there are a lot of physical separation techniques other than that, such as steam distillation, solvent extraction, these things. Okay. So we cannot use any of these techniques to separate something which has been chemically combined. For an example, using filtration, like by using a filter, can we separate hydrogen and oxygen? No, we cannot do that. Okay. So physical methods won't work for the compounds to say in the separation of elements. But when you consider mixtures, for an example, consider sand is there in water. So this is a mixture of water and sand. Can't we separate these two by physical method, which is the filtration? When you filter it, it will separate sand and water. Okay, sand will be retained in the filter. Sand will be retained in filter, and water will pass through the filter or the filter paper. Sand and water can be separated. So I have mentioned those two in the tube. Elements in a compound can be separated by chemical methods. Compounds in a mixture can be separated by physical methods. So, like using a sticky note, if you want, you can have a small note. Okay, I haven't left a space there. No need, because easy to understand. Then next on. Last point, melting points and boiling points. Pure compounds have fixed melting points and boiling point, and mixtures have a range of melting and boiling points. Fourth one, melting points and boiling points. Pure compounds are having fixed melting points and boiling points. For an example, if we take water, that's exact boiling point and melting point. Melting point of water, sorry, what is a liquid? So we need to consider. I'll consider solid. Uh, yeah, I'll consider salt, table salt, sodium chloride. Let me check the exact values and I'll give it to you. Then it is easier for you to remember. Melting point 801. Boiling point 1465. These are rough figures. Huh? So when you consider salt, there's an exact melting point 801. So boiling point is 1465. So when we consider compounds or the pure that comes under pure substance, so pure substances are having fixed melting point and boiling point. But when we consider mixture, that is having a range of melting points and boiling points. For an example, when we consider crude oil, we'll discuss this lesson in organic chemistry. Crude oil is a mixture of different hydrocarbons. This is the thing where like in the petroleum industry, they are doing the purification and where we obtain these like compounds like petrol, diesel, these things. Okay. I'll mention certain components: petrol, diesel, then fuel oil. These are few different compounds. So they are having a range of melting points and boiling points. If we take like these are liquids, these are in the form of liquid. So if we take the boiling points of these three, I'll check and give you the boiling points. You can see for the same mixture based on different components, the mixture is having a range of melting and boiling points. I'll give the exact values. You don't need to memorize these things, just for your understanding, I'm giving these things. In the book, they have not explained up to this scale. So everything I'm explaining with examples in a way which will be easier for you to understand. Crude oil is a mixture of different hydrocarbons. So I have taken only three. So boiling points of petrol will be in the range of 40 to 200. Petrol also consists of different hydrocarbons. Diesel 200 to 250. Fuel oil 350 to 450 Celsius. So you can see different. So what are these? Boiling points only. Huh? I cannot take a melting point for liquid, no. So I'll take the boiling points. So you can see different boiling points are there depending on the compound. So we say like in a mixture there is a range of melting points and boiling points. Okay, please have these two examples. Then we will finish filtration as well, and let's conclude for today after finishing the filtration. The next day I'll discuss solubility. I think I have sent you the tube. Then crystallization, simple distillation, and if the time permits, I'll be discussing about fractional distillation as well. So thereafter only chromatography left. And in the vacation, you don't have any vacation because we are like far behind when compared to the physical classes. I'm having currently two physical classes, so we are far behind already. I have finished up to like ionic bonding, so I need to do a lot of things with you guys as well. And I know especially for lyceumers, like in the first week of September also, like you're having holidays. Can I quickly know about the schools again? I don't remember. Like I remember someone is there from Trinity. Sandil, what is your school? Sandil, what's your school? Trinity College. Okay, you are the one from Trinity College, right? Okay, Chenuka and Sanujan, what are your schools? Chenuka,
Lyceum International School Udigo.
Lyceum, Nugegode.
Yes.
Okay, Sanujan,
Lyceum Kurnagal.
Lyceum Kurunagala. Okay, Sandil, I hope since A level is there ongoing, like you are having vacation at the moment, right? You are in vacation,
Yes,
right?
sir. Yes, sir.
So when the school will starts again, when it will be reopening?
September 8th, sir.
September 8th. Okay. So which means like in first week of September, last week of August, I'll be taking one extra class as well. Okay. Within this month, we'll be able to finish this lesson as well by discussing all the questions. Then we'll be moving to next one, which is atomic structure. In the first week of September, we can finish that. I'll take an extra class. One or two extra classes I'll take during vacation. Then periodic table also, yeah, can be done. As I remember, Sandil, you are in your second or third term, right?
Sir, we just finished second term, sir.
Second term, no? Okay, up
Yes,
to
sir.
which level they have finished in the school? Up to which chapter they have finished in the school?
Sir, metallic bonding.
Metallic bonding.
Yes, sir.
Okay, so you're also facing the exams on 2028 May, right? May June series, right?
Yes, sir.
Okay, okay. Earlier, I used to remember like they had A levels, but have they started O levels newly or was it there already?
Sir, it was there.
Huh?
It was there, sir.
It was there, no? Okay. One of your teachers also teaching here, I don't know whether you know Halana sir, who is teaching mathematics.
I don't know, sir.
Okay. Is he the teacher who is teaching you as well in the school?
No, sir.
Okay. Okay. We are going to discuss the mixture separation techniques. So far, we have discussed regarding the first part of the chapter 2, which is regarding the classification of matter based on the chemical nature. Two main types, pure substances and mixtures. Under that, we discussed the difference between pure substances and mixtures, and under pure substances, we discussed elements and compounds. Apart from these things, we discuss about molecules as well. Okay. Then finally, we discuss about the differences between compounds and mixtures. Now I'll be moving into the mixture separation methods. As I mentioned to you, there are five techniques in the syllabus. We are starting off with filtration. filtration. So please don't pronounce this as filtration. There's no such word. The word is filtration. Let's go through the tube. Filtration is used to separate insoluble solids from a liquid. Example, separating sand from a mixture of sand and water. Then steps of filtration, we need to use a filter paper, then pour the mixture, then filtrate will pass through the filter paper and residue will retain on the filter paper. So when explaining about each of the separation technique, I'll be reminding you again and again what are the differences between these separation methods and how you distinguish, because when we are learning filtration, of course we are learning about filtration, so we are discussing the facts regarding filtration, you know about that, but they will be giving certain case scenarios in the exam where you need to decide, you need to make a decision what type of separation techniques should be used to separate the components of the mixture. In those cases, you should be having a very good idea what are the differences between these mixture separation methods and to which occasions we like whether you can use these individual separation techniques. So since this is the first one, I'll be speaking with regards to filtration. When I start about crystallization, I'll be again coming back to filtration and I'll be explaining you regarding like how to distinguish these two and how these two differs from each other. Then when I move to distillation, I'll be taking the first two again. Likewise, I'll be again and again coming back and explaining you how to distinguish these techniques. Filtration. The first thing you need to remember is it is used to separate an insoluble solid. This is the very important phase. Insoluble solid from a liquid. Example, there's a sample of, there's a mixture of sand and water. Sand is having a higher density, so it will fall into the bottom, and here water is there as a liquid. So we cannot say this as a solution, because solution means something is dissolving, a solid is dissolving in the particular solvent. So we cannot mention this as a solution. So this is a mixture of sand and water. So the liquid phase can be identified separately. So to separate an insoluble solid, this is a very easy example. You know how to separate the sand using filtration. In filtration, what you do, and when discussing about mixture separation techniques, I'll be sharing certain videos for you to watch, which are in the YouTube, which has been done based on the context of edX. Okay. If in future, like I'll be doing these things, and like these are not coming under special practicals in this lesson. There's a practical which is regarding chromatography, but with regards to simple distillation and fractional distillation, also I'll try to give you some kind of an idea when I'm arranging the practicals. But however, I'll be sharing certain videos regarding all these processes. Don't worry about that thing. So how you do that? You take a filter funnel, you pour this mixture into this one. Before that, you need to have a filter paper and fold it into filter paper. How you do it normally? You fold it to two halves, then again fold it back, then you make a cone shape using this one, then you keep it on the filter paper. Then you pour the relevant mixture. So this is the filter paper. There will be sand and here it will be water. Sand will be collected on the filter paper and water will be passing through the filter paper. And the component which is collected on the filter paper is given a special term. You know about these things. Residue, and the one which is passing through the filter paper is considered as the filtrate. Filtrate. Again, I am telling, filtration is a separation technique where you use to separate an insoluble solid, in this case sand. Insoluble means not dissolving in water, where you use to separate an insoluble solid from a liquid. Here we are having a sample of sand and water. You pour the mixture into the filtration setup, then you can separate the two components. How you arrange this setup? You need to take a filter funnel, then you need to fold a filter paper and make it into a cone shape, and you need to place it on the filter funnel. Then you pour the mixture to here. What will happen? Residue will be the sand, which means the component which is retained on the filter paper, and the component which is passing through the filter paper will be the liquid, which is water, and that is considered as the filtrate. So that is regarding filtration. Now with that, I think we will be able to conclude the session for today. Let me check whether I can give you certain questions. As homeworks, I think I have shared the question to TS. Okay. So question number 1, you don't worry about relative form elements. We are going to calculate it later. A Roman number 1, you cannot do the other parts. Then next one, you cannot do. This one you can do. Question number 2, C part. Question number 2, C part you can do. Question number 3, A part you can do. Question number 3, A part you can do. Question number 4, A, B you can do. A, B you can do. Question number 5, part B, C, D you can do. Part B, C you can do. Question number 5, part B, C you can do. Question number 6 you can cut, that is same as, that is a repetition of question number 3. You can cut the entire question. Question number 7, A part you can do. Question number 7, A part you can do. Those are the homework. So we need to start from next day. First of all, I'll be explaining you regarding the solubility. Then because certain concepts are needed for crystallization, then I'll be moving to crystallization. Definitely I'll be able to finish up to fractional distillation. Then we will do some questions that would be better to conclude the session. Then on the last day, chromatography, the practical, and the remaining questions we can finish within 2 days. I can finish We'll continue the next week as usual. Then we'll try to have some extra classes, at least 2 extra classes before the school starts. Then it will be easier for you to perform in the, especially I'm referring for lycemus, it will be easier for you to perform in the October monthly test. Okay. Okay, with that, I would like to conclude the session for today. So thank you for joining and have a nice week ahead. I hope the session was effective and you were able to grasp certain concepts regarding chemistry. Good night.